Hello guys, good afternoon. You are welcome to my YouTube channel, the SPC Tutorials, and my name is Tuton Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In today's video, we shall be treating a before one to comparative vertebrate embryology. Now, the first thing we have to do is to know the meaning of what embryology, and the first person to state embryology. Embryology, in a nutshell, means the study of what embryo. Embryology in a nutshell means what? The study of embryo. What is the meaning of embryo? The embryo of an organism means the juvenile stage of an organism, and it is found in the egg or within the egg or in the body of what? The maternal organism. That is the meaning of what? Embryo. Now, the first person to coin the word embryo was, okay, let me use a better marker, was Carl Ernst. So there's an area before the N, von Bahr. All right, Carl Ernst von Bahr was the first person to state the meaning of what? Embryology, okay? And therefore, he's known as what? The father of embryology. He's known as the father of embryology. Please take note of that. Now, embryology is actually a science, all right? You call it what? Science of embryology. Therefore, you say it is what? The study of the various developments an organism undergoes, okay? The science of embryology means the study of the various developments that an organism undergoes, okay? Now, since it involves developmental stages, okay, you call it what? Developmental biology. Developmental biology, which means that the term embryology can also be called what? Developmental what? Biology. Now, in this course, we are going to be treating two definitions of what? Development. Now, the first one, development means the transformation of a fertilized egg. It is a transformation of what? A fertilized egg and other rudiments that are derived from the parent plant into an adult individual, okay? The board is small, and because of time, I'll just do the dictation, then while you do your writing if possible. I said we are going to be treating two definitions of what? Development. I said the first one means the transformation of a fertilized egg or other rudiments that are derived from the parent what? Organism into a full-grown organism or into an adult organism. Such mechanism is called what? Ontogenetic development. Ontogenetic developments. The transformation of a fertilized egg or other rudiments that are derived from the parent organism into an adult individual is called what? Development. Hence, it is termed ontogenetic what? Development or individual what? Development. Now, the other definition of development means what? The gradual historical transformation. It is a gradual historical transformation of various forms of life, all right, from the simplest to the contemporary what? Diversity of organic life on the planet Earth. I recap, I said it is a gradual historical what? Transformation of the various forms of life from the simplest, which might have occurred first or appeared first, leading to or to the contemporary what? Diversity of organic life on planet Earth. So these are the two definitions of development. I said the first one means what? The transformation of a fertilized egg or other rudiments that are derived from the parent organism into a full grown organism or into an adult organism, and such is called what? Ontogenetic development or developments of organism or developmental what? Individual, okay? Then I said the second definition means what? The gradual historical transformation of various forms of life, all right, from the simplest, which might have occurred first, to the contemporary what stage or diversity of organic life on planet Earth. All right, take note of that. So this is just introduction to what this course. Okay, another meaning of embryology means the study of what ontogenetic developments of organism. It is also the study of ontogenetic developments of organisms. Please, the most commonly known ontogenetic development occurs in multicellular organisms that undergo what? Sexual reproduction, okay? Which means that ontogenetic development occurs mostly in organisms that have the ability to undergo what? Sexual reproduction. Please take note of that. I've given the meaning of embryology, the father of embryology, the meaning of embryo. Okay, now let us take the next one, which is what? Spermatogenesis. Of course, spermatogenesis is not a new topic. We treated it in AB 122. Spermatogenesis means the production of the sperm or what? Spermatozoa. Where is the blood wrapper? Oh my god. It is the production of, excuse me, it is the production of what? Sperm or spermatozoa. Where does it occur? It occurs in the seminiferous tubule of the testes, all right? It occurs in the seminiferous tubule, all right, of the testes. Spermatogenesis means the production of sperm or spermatozoa, and it occurs in the seminiferous tubule of the testes. How does it occur? First thing first, the premodal cell, the premodal germ cell, let me use the word germ cell, would undergo mitosis repeatedly to produce what? A sperma, to produce spermatogonia. Right? It will undergo what? Mitosis to produce spermatogonia. Spermatogonia are actually what? Diploid. Spermatogonium is singular, but spermatogonia are what? Plural. Okay, so it is diploid. Now, as soon as the spermatogonia are formed, what happens? It would increase in size to produce what? Primary spermatocytes. All right, it will increase in size to produce what? Primary spermatocyte. And it is this primary spermatocyte that is called what? The sperm mother cell. All right, the sperm mother cell, and that is what? Primary spermatocyte. Now this primary spermatocyte would undergo meiosis. There is two meiotic division. The first one produces what? A secondary spermatocytes. All right, the first meiotic division will produce what? Secondary spermatocytes, while the second meiotic division produce what? Four spermatids. Right, it will produce what? Four spermatids. Now these four spermatids produced will now undergo what? Differentiation to produce what? A spermatosome. Spermatosome. Now this spermatosome produced has head and tail. So you can therefore say that it is what? Motile, because it uses what? Tail for movement or locomotion. So please, the spermatocyte produced enters into the prophase of meiotic what? Division. All right, meiotic division. Now the prophase is the phase that is characterized by the condensation of chromatids to produce a visible chromosome, which means when the chromatids are condensed, they produce what? Chromosome. That is what? The prophase stage. But that is in mitosis. But in meiosis, it is divided into 5 stages: the leptotin, the zygotin, the pachytin, the diakinase, and which one again? I think we have leptotin, we have pachatine, we have diplutin, and we have what? Diakinase. So these are the first stages, but we are not going to that. I'm just telling you that this primary spermatocyte enters into the prophase stage of what? Meiosis. Take note of that. So this is how spermagenesis what occurs in a male animal. Please take note of it. The primary germ cell, the primary germ cell originates from the germinal epithelium cell. All right, this primordial germ cell that undergoes mitosis originates from the germinal epithelium cell, and this cell is found lining the outside of the seminiferous tubule of this tubule. Now, this germinal epithelium cell lining the outside of this tubule produce what? The primordial germ cell, which means that it is this cell that gives rise to this other one. This one is found surrounding the outer part of this tubule. Now, it is inside this tubule you have the complete development of the spermatozoa from the spermatids. How does it happen? Now, 4 spermatids have been produced. What now happen? These daughter cells produced will now move to the tubule, to the upper part of what? The tubule. Now, once they get there, these spermatids will differentiate to produce what? Spermatozoa. To produce spermatozoa. As soon as spermatozoa is formed, it then develops what? The head. And this head is found enveloped inside what is called the Sertoli cell, right? Which means that the complete development of the spermatozoa from the spermatids occurs in the lumen of what? The tubule. That is the wall of the tubule that is adjacent to the lumen. That is where these spermatids are differentiated or developed into the spermatozoa. Now, once this spermatozoa is produced, it forms what? The head. And this head is enveloped inside what? The Sertoli cell. The function of this Sertoli cell is to nourish what? The sperm, which means that it acts as what? A nurse body. It acts as what? Nurse body. That is, it provides nourishment for the sperm. Take note of that. Okay, is there any other one? So I've given you the processes that take place during spermatogenesis, but let me illustrate it. I think it's good I do the illustration. So please just follow it bit by bit to understand it very well. I shall be putting a lot of diagrams on the board. I have 2n. Space. This is a primordial germ cell, right? And this is what? The spermatogonia. Spermatogonia. Now this phase here, this phase is called what? The mitotic phase. Mitotic phase. Mitotic phase. Now, under the growth phase, this here, from here like this, you have the growth phase. The growth phase. Now, this diploid entity will produce haploid chromosome. All right, this haploid chromosome would differentiate and have N, 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 N. Now from these four spermatids, now I told you that as soon as this spermatogonia are produced, I said from here upward you have what? You have it to be the mitotic phase. Now this spermatogonia produced will increase in size to produce what? The primary spermatocytes. Primary spermatocytes. And this is what? The growth. Okay, look at this is the growth phase. The growth phase is here, and this is the mitotic phase. Sorry, or meiotic phase. Oh God, meiotic phase. Pardon me for that. Meiotic phase. Now, as soon as these primary spermatocytes undergo the primary first meiotic division, it will produce what? Secondary spermatocytes. And the second division produces what? 4 spermatids. So these are the 4 spermatids produced. Now these spermatids produced would undergo differentiation to produce sperm. Alright, so these are what? The spermatozoa. Spermatozoa has the head, neck, and tail. Alright, so this is a full illustration of what? Formation of spermatozoa. So this illustration here has to do with formation of spermatozoa. Primordial germ cell would undergo mitosis to produce what? Spermatogonia. Spermatogonia will increase in size to produce what? Primary spermatocytes. Spermatocytes will undergo mitotic division or meiotic division, that is meiosis, to produce second spermatocytes and 4 spermatids. Now this 4 spermatids will undergo what? Differentiation. It will undergo differentiation to produce what? The spermatozoa. Right, so that is what you have it to be. So at this point we call it a day on formation of spermatozoa. So just looking at what we have on the board, you will deduce that it is worth reading. So just look at it very well, because I'm about taking another step. This is what you have. Okay, can I take the next one? So since you've known this one already, let's take another part. Now I told you that spermatogenesis, which means the formation of the sperm, it occurs in the seminiferous tubules of the testes. Now please take notes. Longitudinal, okay. All right. Longitudinal section of the testes shows the seminiferous tubule. Take note of that. Seminiferous what? Tubule. The longitudinal section of the testes shows what? The seminiferous tubule, numerous seminiferous tubule. How does it look like? Let me see if I can put an illustration on the board. So these are seminiferous tubule, and this place is called the vas deferens. This vas deferens is also called what? Sperm ducts. You also have something like this. So this place is the epididymis. So this part is called the vas deferens. Now these thread-like structures are actually what? The seminiferous what? Tubule. And this part, okay, this part is called the vasa efferentia. Alright, so which means that the longitudinal section of the testis will show what? The seminiferous tubule. And this is what you have it to be. Please take note of the diagram, very, very important. Now, this is the seminiferous tubule, and this is what? The vas deferens. The vas deferens, you know, is also called what? The sperm duct. Now, why the epididymis is that region where the sperm is stored until it gets to maturity. It is the region where the sperm is stored before it gets to until it gets to what? Maturity. Now, while the vasa efferentia is the part that runs from the epidermis to the vas deferens. It runs from the epidermis to the what? The vas deferens. So please take note of that. So this is the longitudinal section of the testis showing the seminiferous tubule. Please take note of that. In some animals, when the seminiferous tubule is caught in any division, you have what? Okay, I think I can rub off this diagram now, right? So just take note of what you have here. These thread-like structures are called the tubules. We have the vasa efferentia, vas deferens, and the epididymis. Please take note of that. Okay, is there any other one? Okay, to show embryogenesis, I told us that the formation of embryo is called what? Embryogenesis, okay? While the study of embryo is called embryology. While embryo is a juvenile stage of an animal that is found in the egg, that is within the egg membrane or in the body of the maternal organism. Now, what is the mechanism behind embryogenesis? Is very long. Let's try it. Now we have the gametes. All right. Now you know that this gamete we have the egg, which is, if I don't call it egg, I can also call it what? Ova. Or egg, and we have what? Sperm. If I don't call it sperm, I'll call it what? Spermatozoa. Now the fusion of this egg and spermatozoa produce what? That is through fertilization. Okay, fertilization. Oh God, this space not be enough for God. Let me turn it. Excuse me, let me turn the board. This space will not be enough for that. Please let me check if it's okay. Stand up, stand up. Is it showing down? Let us just leave it like this then. Let's do it like this. I'll manage it. Alright, so you have fertilization, which will now produce what? Zygotes. The fusion of the egg or ova and the sperm through fertilization produce what? Zygote. Now this zygote is actually what? Diploid. And this zygote will produce what? New individual. Which means that the development of the zygotes, okay, wait. Once zygote is formed, it develops into what? New individual, and this zygote is what? Diploid. Now, as soon as this zygote is produced, it undergoes what? Cleavage. Alright, it undergoes cleavage. Now, cleavage means the division of these daughter cells, of these zygotes produced. That is division of, okay, after zygote, is it, okay, yeah, division of All right. Now after cleavage, you now have gastrulation. Then after gastrulation, you now have which one again? Organogenesis. Organogenesis. After organogenesis, you now have growth and histological development. All right, let me take it again. The fusion of the egg and the sperm is called what? Fertilization, and it produces what? The zygotes. And this zygote, once it develops, it produces what? A new individual. Now, this zygote would undergo what? Cleavage. Then it will produce what? It's after undergoing cleavage, it will now undergo what? Gastrulation. Now, this word gastrulation means the arrangement of cells into different groups and distinct layers. All right, it is the arrangement of what? Cells into different groups and distinct what? Layers. Now, after gastrulation, it will now undergo what? Organogenesis, which is the formation. This is the formation of organ and organ system. All right, so this, okay, let me show you where embryogenesis actually stops. Okay, it stops here. Formation of zygotes, it stops here. All right, so here you have what? Embryogenesis. All right, that is where it stops at the formation of what? Zygote. Okay, that is what you have it to be. So please take note of that. Fusion will result to what? Zygote formation, which will develop to produce what? A new individual. It would undergo cleavage. You now have the next one, which is what? Gastrulation, the arrangement of daughter cells into different groups and what? Distinct layers. You now have what? Organogenesis, which is formation of organ and organ what? System. Therefore, you now have growth and what? Histological what? Development. So that is for that. Is there any other part that I should take? Okay, now let us take the next step. Let's take the next step. Now, the sperm and seeds, I told us that when the sperm and seeds undergo differentiation, it produces the spermatozoon, having head and what? Tail. Having head and tail. What is a short description of the spermatid? The spermatid is an elongated cell. Is an what? Elongated cell with spherical, bulky, and prominent nucleus. All right, it is an elongated cell with spherical, bulky, and what? Prominent nucleus that undergo transition into sperm. Yeah, I told you that the spermatozoa or the sperm is produced from the first spermatid produced during what? Spermatogenesis. However, for these spermatids to differentiate or transit into sperm or spermatozoa, it undergoes 4 transitional stages. 4. The first one, you have um, elongation. There is the spermatids. The spermatids would undergo what? Elongation. Now, after undergoing elongation, the nucleus, would shrink. As it loses water. As it loses what? Water. That is, then another one. Okay, wait, let me put it better. Let me do it better. Sorry. Done. We have elongation of the spermatids. Elongation of the spermatids. We have then and secondly, you now have removal, or how do I put it now? Some cytoplasm, ribosomes, lysosomes, and endoplasmic reticulum are thrown away through what? Pinocytosis. Pinocytosis. Okay. Now, after that, what happens? There's also what? Removal. There's also removal of all RNA and nucleolus. All right. So these are the stages that the spermatids must undergo. Okay. Now, on a broad note, the spermatids would elongate. After elongation, the nucleus will shrink. Okay, the nucleus will shrink. Nucleus shrink. Now, as soon as it shrinks, what happens? There is what? Removal of water. It loses water from the nuclear pore. It loses water from the nuclear pore. That is for that. And there's also the packing of chromosomes. Chromosomes are partly brought together in small volume to reduce the weight of the sperm. I said one, there's elongation of the sperm, the shrinking of the nucleus by losing water from the nuclear pore. It loses water from the nuclear pore, and chromosomes are closely packed together into what? Small volume to reduce the weight of the sperm so it can move what? Freely. The second stage is the removal of what? Cytoplasm and other cellular materials such as ribosomes, lysosome, and plasma reticulum through what? Pinocytosis, which means that through pinocytosis, all these organelles are thrown away from the nucleus, from the cell of the spermatids. Okay, is there another one? Though we have the elimination of these entities, please take note. Golgi bodies, centrioles, and mitochondria are retained though. Please take note of that. Cytoplasm, ribosomes, lysosome, and endoplasmic reticulum are thrown away through pinocytosis, but Golgi bodies, centrioles, and mitochondria are retained. They are not thrown away. Then the third stage is what? The removal of all RNA and what? Nucleolus. This is the third stage. And which other one again? The fourth one is the formation of what? Acrosome. formation of acrosome. Formation of acrosome. Alright, so this illustration you have here is what? Transition of the spermatids. It shows transition of the spermatids into what? Sperm. Elongation of the spermatid. The nucleus will shrink because it has lost water from the nuclear pore, and the chromosomes are closely packed together in the form of what? Into small volume to reduce the weight of the sperm. And secondly, some cytoplasm ribosomes, and these are removed from the spermatids, but Golgi bodies, centrioles, and mitochondria are retained. They are not what? Removed. And thirdly, you have the removal of all ribonucleic acid and what? Nucleus. Then fourthly, formation of what? Acrosome. For an acrosome to be formed, the Golgi bodies must take part. It therefore means that the acrosome is formed from the Golgi bodies. How does it happen? Let's take it. Away. The Lord is our strength. Okay. Now the first stage is quite long. It's long. That is formation of what? The acrosome. Now, for this acrosome to be formed, what will happen? The Golgi bodies will aggregate themselves. They would aggregate themselves round the vacuoles. All right. The aggregation of the Golgi bodies round the vacuoles will lead to what? Acrosomal what? Formation. But that is not it. Now, as soon as they aggregate themselves around these vacuoles, inside these vacuoles, you have there may be two or more or one or more vacuole, and they will increase in size. They will undergo what? Enlargement. They would undergo what? Enlargement. And inside this vacuole, you have dense body. This dense body found inside the vacuole is called proacrosomal granule. Right? I said for the acrosome to be formed, what happens? The Golgi bodies would aggregate themselves around the vacuoles. Now I said inside the vacuoles we have dense body called what? Proacrosomal granule. I said there may be two or more vacuoles which will undergo what? Enlargement. Now, as soon as this proacrosomal granule is formed, it will increase in size. It will increase in size to produce what? Acrosomal granule. Now, it is this acrosomal granule that forms the core of what? Acrosome. Which means that it is this one that forms the actual acrosome. The acrosome is that part that is found, it is found in the head, and it has what? Lysosome. This lysosome has hydrolytic enzyme that dissolves the egg during fertilization. I said the Golgi bodies will arrange themselves around the vacuoles, and I said there may be one or two vacuoles which will undergo what? Enlargements. Then inside the vacuoles we have dense body. These dense bodies are called what? Proacrosomal granules. Now these proacrosomal granules would undergo what? Increase. It will increase in size to produce what? Acrosomal granule. It is this acrosomal granule that will now produce this acrosome. Now this acrosome is found in the head. It has a lysosome. Inside the lysosome we have the hydrolytic enzyme that dissolves the egg during what? Fertilization. Okay, please take note of that. Take note of that. That is not the end. Now that we have the formation of the acrosome already, the vacuole, please take notes. If there is more than one vacuoles, they will fuse to form one vacuole. If you have two or more vacuoles, they will fuse together to form only one vacuole. Now this vacuole will, okay, with its granules. That is, this granule now is what? Is what? The acrosome, right? The acrosome. Now, they are found at the top of the nucleus. They are found at the top of the nucleus. They are found at the top of the nucleus. Now, the vacuole will increase, will lose its liquid contents. As soon as it loses its liquid content, what happens? It will spread and cover this granule. All right, it will spread. As soon as it loses its liquid contents, it will spread and what? Cover this what? Granule. Meanwhile, this nucleus, half of this nucleus is now covered by what is called cap. The cap is what? A double membrane. So that is what you have it to be. Now, acrosomal granule is formed from the proacrosomal what? Granule, and it is this CDO that forms what? The acrosome. The acrosome, I said, has lysosome with hydrolytic enzyme that dissolves the egg during what? Fertilization. And I said when there's more than one vacuoles, they fuse together to form just one vacuole. Now this vacuole with its granules are found at the top of what? The nucleus. Okay. Now the vacuole will lose its liquid contents and spread over the what? The granule. Then the nucleus is covered by a double membrane called what? The cap. The cap is that double membrane that covers the front half of what? The nucleus. It covers half of the nucleus at what? The front. So please take note of that. As soon as this, oh God. Okay, that is formation of the acrosome. Let us illustrate it diagrammatically. Let me see if I can do that. I have something like this. Away. You have now these are Golgi bodies. Now I have another one. This is a proacrosomal granule. You can see Golgi bodies would arrange themselves around the vacuole, then to produce what? This proacrosomal is found inside the vacuole, which is this one. I told that this proacrosomal granule will increase in size to produce. Let me do it, please. So this is acrosomal granule. All right. So this is the first stage. The Golgi bodies vary themselves. The formation of what? The proacrosomal granule inside the vacuole. Now this proacrosomal granule will increase in size. You can see it as increase in size to produce what? The acrosomal what? Granules. Okay. Now some of the Golgi bodies would degenerate. Okay, that is, some of the Golgi bodies become what? Golgi rests. Let me illustrate it. Pardon my diagrams. It is good we draw. Understand? So you have something like this. All right. You have So these are called the Golgi rests. And this is acrosomal vesicle. Acrosomal what? Vesicle. Then after that, you now have like this. They have so that is what you have, which means that it is this acrosomal vesicle that produces what? The cap. Right, you can see now that this acrosomal vesicle has differentiated into what? Let me do this very well, please. Alright, so what you have on the board is called what? Formation of acrosome. Acrosomal formation. Alright. Now I said the Golgi bodies arrange themselves around the vacuole, and I said inside the vacuole we have the proacrosomal granule, which would increase in size to produce the acrosomal what? Granule. Now I said that some of the Golgi bodies will become what? Golgi rests. Now these Golgi rests, they are not functional, they degenerate, or they undergo what? Regression. You now have what? The acrosomal vesicle. Now this acrosomal vesicle will now produce what? The cap. You can see now that acrosome has been formed successfully, and you now have what? The plasma membrane surrounding it. So this is formation of the acrosome. Just do it bit by bit. Just try to understand the diagrams. From the diagrams you can even coin out one or two things. All right, from the diagrams, if you can actually understand the diagram, you can coin out one or two things even if you forget it. Okay, so I think, is there another one? I think, oh yes. Now let us discuss the spermatozoa. The spermatozoa, of course, the spermatozoa is, hope is recording. Yes, thank God. The spermatozoa is the male sex cell. Of course, everybody knows that it is a male sex cell. It is a male sex cell. It has a head. It has flattened head, cylindrical body, and what? A tail. Okay, please take notes. For the sperm to move effectively, it must have what? A streamlined body. It must have a streamlined body. For the sperm to move properly, it must have a streamlined body, and this is characterized by light weights, and what? Locomotory organ, which is what? The tail or flagella, as the case may be. For it to move well, it must have light weights and locomotory organ. Take note of that. Now, please, the nucleus. Oh, the nucleus very organisms have different shapes. Thank God I just remembered. In man and bull, the nucleus is ovoid and flattened. In bull and man, the nucleus is what? Ovoid, okay? But in birds and mollusks, it is spirally twisted like a corkscrew. All right. In birds and mollusks, it is spirally twisted like a corkscrew. Okay. But in bivalve mollusk, it is almost what? Round in shape. It is almost round in shape, which means that it is not completely round in shape. So please take note of that. Now, the sperm has the head, and the head of the sperm has the nucleus having haploid chromosome. Okay, it has the head. Now, this head has a nucleus with haploid chromosome. Now, this same head also possesses what? The acrosome. The acrosome possesses what? A lytic enzyme. And this lytic enzyme it possesses helps in dissolving the egg during what? Fertilization. It has the neck. It has the neck. Now, this neck has the centriole. It is this neck region that you have the mitochondria. Of course, the mitochondria is known as what? The powerhouse of the cell. It is this mitochondria that produces energy for the lashing movement of the tail of the sperm. Okay. Now you now have the middle piece. We have the middle piece. The middle piece is actually the first division of the tail, and you have the asia filaments. You have the asia filaments in the middle piece, which is the first division of the long tail. Okay, I think before this I would have taken. Okay, let me just continue. Let me continue. I'll Okay, I'll explain it diagrammatically. I wanted to tell us something before doing this. But since I've started, let us just take it. Now, the middle piece, you have the asia filaments. The neck, you have the centrioles, okay? Um, okay. It is the middle piece you have, sorry. No, it's not done like that. It is the middle piece you have the asia filament and mitochondria. All right. Mitochondria and filaments are found in the middle piece of the sperm, okay? And it has the tail. Now the tail is long. I said the first division of the tail is called what? The middle piece. The first division of the tail is called what? The middle piece. And this middle piece has the asia and the asia filament and what? The mitochondria. Okay. Now, looking at the sperm, the asia filament runs down the full length of the sperm. The asia filament is actually found through from the neck down to the tail, except the tail piece. Is it tail? Yes, tail piece. Okay. Now, uh, please in the long tail that is in this tail I'm talking of, the tail has the asia filament that is found in the tail is surrounded by the mitochondria. Let me draw the sperm so you understand what I'm saying. Let me draw it for a better understanding. Because right now it's becoming confusing. Let me draw it. Okay. I pray this board accommodate everything now. Uh, have here, these are the mitochondria. I believe it's okay, like, okay. These are, you have the mitochondria, and you have this place called the asia filaments. Asia filaments. You have this one is called the proximal centriole, and this is called the distal centriole. So you have the asia filaments, you have the tail, you have the end piece. Okay, so you have this very one, of course, is the acrosome. Acrosome, and this is the nucleus, which is rich in DNA, as it has a lot of what? DNA. So the sperm is divided into head, to the head, neck, to the head, neck, middle piece. I say the middle piece is where you have the mitochondria and what? The asia filaments. So you now have from here, you have the long tail. So these very parts, let me just stop it here. This very part is called this is the end. This is the end piece. So this is a diagram of the sperm. Now, looking at the acrosome, is found inside the head. It has what? Lytic enzyme that dissolves the egg during what? Fertilization. I said the nucleus is rich in what? DNA. Now, the proximal centriole is that centriole that is found in, okay, how do I put it now? Okay, fine. As soon as this chromosome is produced, the centriole, you have two centrioles found in the upper and lower region of the sperm, that is under the what? Nucleus. You have two centrioles and they are right angle to what? Each other. Now, there's this depression that is found under the what? Nucleus. This is the nucleus. This depression that is found under the nucleus has what? The proximal centriole. This proximal centriole, I said, is found in this depression that is found under the nucleus, the posterior region of what? The nucleus. Now, the distal centriole is perpendicular to the proximal centriole. It is what? Perpendicular to the proximal centriole. Now, the asia filament is produced by the distal centriole. Now, this asia filament is actually called what? The basal body, and it is what? Supportive. Provides support. Okay, it provides support. I said the acrosome, once the acrosome is formed, you have two centrioles that are right angle to each other. Now, the one that is found in the depression that is found between the that is found under the nucleus is called what? The proximal centriole. Now, the Perpendicularly to the proximal centriole, you have what? The distal centriole. It is this distal centriole that is found, that is produced, or that produces the axial filament. It produces this axial filament that runs down through the length of what? The sperm. And this axial filament is called what? Basal body, that provides what? Support. Okay, so um sometimes the sperm may have both cilia and flagella. Cilia and flagella are for what? Locomotion, okay? They are for locomotion. Now, this distal centriole and this axial filaments, this distal centriole and the axial filaments are surrounded by the mitochondria. You can see it is this axial filament that runs down. So you can see now that the what is it called now? The mitochondria surrounds it. You can see the axial filament and the uh, distal centriole are surrounded by the mitochondria, and the mitochondria could appear in different forms in different animals. In some animals, the mitochondria fuse to form a continuous body. All right. In some animals, the mitochondria will fuse together to form what? A continuous body round the axial filaments. All right. The mitochondria will fuse to form a continuous body round the axial filament. While in some other animals, the mitochondria will form clumps. These clumps produced by the mitochondria are arranged alongside the axial filaments. They are found alongside the axial filament, while in other animals they are just found surrounding or found around the axial filament, while some they are found as clumps alongside the axial filament. Please take note, in the long tail, the axial filament, though it's not visible here, there is a long tail. The axial filament found there is surrounded by both mitochondria and what? Cytoplasm. It's surrounded by both mitochondria and cytoplasm. So at this point, we'll call it a day. We've come to the end of spermatogenesis. So in my next class, we are going to be treating oogenesis. Hope I did not jump anything. Okay, I gave us the 71st tube diagram. I gave us this diagram of the sperm, then formation of the acrosome. Okay, then formation of the sperm. That is 4 diagrams. Okay, I believe that is all for now. That is all for now. So at this point, we'll call it a day. Thanks for watching. Do have a wonderful day. Please, thanks, and endeavor to subscribe.